Hey, good people. Let us look at this application here of your vertical projectiles. Then we can do horizontal projectiles thereafter. All right. We are given an information here. I'll be doing two questions. Please bear with me. A bricklayer throws a brick vertically upwards. Here's a bricklayer on the ground floor. Right. He's throwing a brick vertically upwards. Okay. There's another bricklayer standing on the scaffold. Another bricklayer standing on the scaffold. That one is blind. They say he fails. He fails to catch the brick and it falls back into the hands of the thrower. After, now the brick came back, right, to the thrower's hand. After 1,8 seconds. Now, the given time there is time total 1,8 seconds. It's for upward motion and downward motion. Okay. If we want for upward motion only T upward motion, it will be 1,8 divided by 2, then we get 0.9 seconds. Okay. That means it took 0.9 seconds to go up and it took another 0.9 seconds to come back to the ground floor. Now, they want us to calculate the velocity of the brick when it leaves the thrower's hand. That is the initial velocity. That's what we are looking for. We are looking for initial velocity because the initial velocity of the thrower's hand, it has to be at maximum. Okay, that's what they are looking for. Now, in calculating that, we'll be using this formula V equals to U minus GT. Remember, we are acting against gravity, hence G there, it is negative. It is negative there. Now, our V, it is 0. We are having V equals to U minus 9,8 multiplied by the time, 0.9. Then when we transpose this to the right-hand side, it will be U equals to 9,8 multiplied by 0.9. Then we get our answer as the initial velocity as 8,82 meters per second. Okay, please verify that with me. Okay, then the second question, they want us to calculate how high the brick travels after leaving the hands of the thrower. Now, this is what they want us to calculate. They want us to calculate this height. That's what they want us to calculate. They want us to calculate the height. Now, in calculating the height, we will be using this formula. All right. In calculating the height, it will be V squared equals to U squared. We are acting against gravity. It will be minus 2GS. Okay. Our V, it is 0. Then when we transpose this to the other side, it will be 2GS equals to U squared. S would be our U, it is 8,8. 2 squared divided by 2 times 9,8. Then I get my answer as 3,969 meters. That would be 4 meters. Okay. This is how you tackle this question. Let's look at the second question then. Let's look at the second question. The second question is so interesting. An object is dropped vertically downwards from a point 300 meters above ground level. Now, let's write our building there. That's our building. We are told that our building, it is 300 meters. That's what they are saying. A point above ground level. That means this person is standing, okay, all right. That means this person is standing on top of this building, okay? Then, yes. An object is dropped vertically downwards, yes. Standing on that top of that building, and the height of that building, it is 300. Then he throws an object downwards, okay? The object that's going down. The object that's going down, right? At the same time, another object that's projected vertically upwards. Now, at the same time, there's another Galagoon standing on the ground floor, throwing an object upwards. The object is going up. the object that's going up, right? That's what we are told there. Is projected vertically upwards from ground level, vertically below the first object with an initial velocity of, now the initial velocity here, it is given as 100 meters per second. The initial velocity of the object thrown from the ground level going up, it is 100 meters per second. Calculate the following: the time taken for the object to collide. They want us to calculate the time taken for the object to collide somewhere there. That's where our collision took place. That's where our collision took place. That's what we need to calculate. It took how long for those objects to collide? All right, that's what we have to calculate. Now, in calculating this, it is easy. We are given the total displacement there. The height, it is 300. That means our height, it is st. It is 300. Then we are having this one throwing an object downwards. Now we will be denoting that one as our S1. Then this one who's throwing the object from the ground floor going up, we will denote him as S2. Because this two scenarios, they occurred within that 300 meter. Okay, that means we are having ST equals to S1 plus S2. They occurred within that. Okay, now we are looking for collision, for that collision, between, in between, right? That's what we are looking for. Now, the first one is going up. We know that it will be U. It is UT. It is for gravity. It will be plus 1 over 2 GT squared. That is the first one. Plus, the second one would be UT, open bracket, minus, he's against gravity, 1 over 2 GT squared, close bracket. Now, we know that the U here for this one, the U there, it is what? It is 0 meters per second. That means we are having 0 there. It will be 1 over 2 GT squared, right? Plus UT minus 1 over 2 GT squared. This is what we have. Now, when we add the like terms, this one and this one, when we add them, they will give us 0, because here it's a negative there. Okay, when we add the 2, it will give us what? 0. They will fall out. Then we are left with ST equals to UT. Then our U, it is this U here that we are left with. Therefore, our T would be ST divided by what? By U. It is 300 divided by 100. Then our time taken, it is 3 seconds. Now, it took 3 seconds for this object to collide. Now, the second question, they want us to calculate the height of the point of collision above ground level. They want us to use this one, the S2 one, to calculate the height. Now, in calculating that, it will be S equals to UT. He's acting against gravity, negative 1 over 2 GT squared. The initial velocity there, it is 100 multiplied by 3 minus 1 over 2 multiplied by 9,8 multiplied by 3 squared. Then we get our answer for height as, let's work it out. It is 300 minus 0.5 times 9,8 multiplied by 9, close bracket. Then we get our answer as 255,9 meters. Now the height, what's my writing to now? The height, it is 255.9 meters. This is where it collided from, when you're looking at from the bottom going up. Then from top going down, it will be 44 comma something, because you have to say 255. When you minus that from 300, then you get your answer is 44.1. It means if they said we should calculate it from the top, then the height was going to be 44.1. But the fact that they said from the ground level, this is the route that we need to take in calculating that. This is how you tackle these questions, good people. Thank you, good people. We are done with the vertical projectile. I'll be posting the horizontal projectile now. Thank you, good people.